All right, we're continuing our discussion of laboratory and SI, where we're looking at setting up problems dealing with converting units from English to metric system or the other way around, and also within metric system. Of course, in science, we use metric system exclusively, and use of prefixes is quite common, and it's important for you to know what these prefixes mean and how they're used in calculations. So we're going to look at some examples that I pulled, some of them right out of your lab manual, that looks at International System of Units, which is of course based on metric system. So the first example we're going to look at is use of prefixes in conversions. And the first example I'd like us to take a look at is converting 12.5 kilograms to milligrams. So if you look at table D11, which I referred to earlier in my first video, you will see a listing of various prefixes, and on the top of the page you will see prefixes that show fraction of a unit, and towards the bottom of the table you will see prefixes showing multiples of a unit. So I pulled out two prefixes here. Kilo, which is designated by K, stands for 10 to the third of a unit, so it's multiple of a unit, while milligram here, M here stands for milli, that means 1,000th of a unit, or 1 times 10 to a negative third of a unit. And so it's a fraction of a unit. So before we start converting, we need to look up the meaning of these prefixes, or presumably we would know what they mean. For example, here for milligram, like I already mentioned, it's 1 times 10 to a negative third of a gram, 1,000th of a gram. Notice, of course, that all these prefixes go by order of 10, so they represent either 1/10 or 100th or 1,000th or 1,000,000th of a unit. And then before we set it up, we need to plan. And the plan here, like shown in example 1 in your lab manual for, I think it's page 54, the plan is always to start with the first prefix given, convert to the main unit, which in this case would be gram, so there's no prefix here because it's a main unit, and then from main unit to go to second prefix. And this will be always the theme, and you would always be expected to do it like this. So here is my setup. I start with 12.5 kilograms because that's what I'm given, and I'm setting this up in a way so that kilograms, 1 kilogram here, would be on the bottom of my ratio, and 1 times 10 to a third gram would be on top. Why am I setting it up this way? Well, because the goal here is to cancel out or get rid of the kilograms. So 1 kilogram should be on the bottom, and 1 times 10 to a third gram should be on top. This allows me to cancel my kilograms, and at this point, if I were to stop my conversion, the unit would be grams. But grams is not what I want as my eventual answer, because I'm supposed to convert to milligrams here. And so what I'm doing up here is I'm taking it further by putting 1 milligram on the top and 1 times 10 to a negative third of a gram on the bottom. Again, the big question is, why is 1 milligram on top and 1 times 10 to a negative third is on the bottom? Well, in this case, I want to get rid of grams and keep my milligrams as my unit of my final answer. And so I want to cancel grams, and that's why I'm putting 1 times 10 to a negative third grams on the bottom. In order to avoid guessing, I strongly suggest you always write it out like this, at least in the beginning, while you're getting used to doing problems like this. Set it up like in equality, like I did up here, so you know that 1 times 10 to a negative third goes with grams, while 1 in this instance goes with milligrams. So I know that 1 goes on top and 1 times 10 to a negative third goes on the bottom. And then of course I do the math. Here we're dividing by 10 to the negative third, which is the same as multiplying by 1,000. So my final answer comes out to be 12.5 times 10 to the 6th of a milligram, or 1.25 times 10 to the 7th, 10 to the 7th milligram. So this is how I would write it in scientific notation. This would be the preferred answer, but if you did this and didn't go this extra step, you would still theoretically get full credit because it is numerically correct. So my advice is you need to do some practicing, and this is what this exercise is mainly for. And the more you practice, the more you set these things up like this, and if you follow my advice and set it up in steps, you should, number one, get the problem right, which of course is the goal, but you would also see how it all comes together, and it will help you remember these prefixes and understand how to use them in calculations correctly. Now we're going to go to our second example. Here we're dealing with, I switched from grams to meters, which of course is a unit of length, and I picked 1452 nanometers and converting it to micrometers. So two other prefixes that I bold here include nano, which is according to table D11 stands for 10 to negative 9th of a main unit, in this case meter. This here is a Greek letter U that in scientific notation and in scientific literature represents micro, which is very different from milli, and micro stands of course for 1 times 10 to negative 6. Here it should be times sign. So 1 times 10 to negative 6 of a meter. So we have to convert nanometers to meters, and once again we're doing it by planning it out step by step. Again, this is my strong advice to do it that way. Nanometers for 2 meters, main unit, and then from main unit meters to micrometers. Again, this is pronounced micro. Do not confuse it with milli. Very different prefix, very different meaning. So here we're doing the setup, starting with 1452 nanometers. And here I have to go from nanometers to meters. So I want my meters to be on top and my nanometers to be on the bottom, so nanometers would cancel. The unit associated with nanometer here is 1. So 1 nanometer goes on the bottom, 1 times 10 to negative 9th meter goes on top. Again, if I was to stop right here with my conversions, my nanometers would have canceled and the unit remaining would be meters. And then the next step here, I still have to go on because my next step is from meters to micrometers. 1 micrometer equals 1 times 10 to negative 6 meter. I want to put meters on the bottom, and the number associated with meters, numerical value here is 1 times 10 to negative 6. This should go on the bottom because I want to cancel my meters from up here, and 1 micrometer would go on top, and then I do the math, and what I get is 1452 times 10 to negative 3rd by doing the powers here, micrometers, and then of course I can move my decimal point 3 places and I would get 1.452 micrometers. So either answer represented like this or like this would be considered correct. One last example having to do with prefixes, and here I sort of wanted to pick not just some abstract number but something fun from something that may be familiar to you. So here we're looking at 21.1 gigawatts of power. This capital W stands for watt, which is main unit of power. And typically if we were in a regular classroom at this point, I would ask if someone might recognize this from popular culture. And usually I do get people who tell me yes, they are familiar with this. And this of course is from one of my favorite movies, Back to the Future. And if you recall that movie, this was the amount of power, according to the doc, needed for time travel. So we're going to look at converting 21.1 gigawatts of power to kilowatts. Kilowatt might be something you might be familiar with, because if you've ever seen any sort of bill for electricity that comes to our houses and apartments, typically the amount of power used by a household in, say, a month are represented in kilowatts. So here again, first we look up the relevant prefixes using table D11. 1 gigawatt of power would be 1 times 10 to the 9th over watt, and 1 kilowatt would be 1 times 10 to a third watt. So basically 1 kilowatt is 1,000 watts. And the plan here would be, once again, to start with first prefix, in this case gigawatt, go to main unit, which is watt, and then from main unit to kilowatt. And the setup is shown right here. Hopefully you can maybe look away for a minute from the video, get a piece of paper and a pencil and try to set it up yourself, and then compare your answer to mine. But you will see I'm following the exact same logic. I'm trying to set it up so that the unit I don't want, in this case gigawatt, goes on the bottom, and then I get to watts, and then from watts to kilowatts. So this completes the second video, which obviously covers conversion between prefixes. In the next video of the series, we will look at some problems from the problem set, where we will look at conversions between English and metric system.